Hi there, good morning. Thanks for joining, Casey. Today we're going to be showing your students, I'm not sure if you're a student or an educator, we're going to show you guys some techniques, things you can do with dry ice. This is your third day of Don't Try This at Home. So thank you for joining and welcome. I'm Mr. Zach, and of course you know this is Ms. Sarah.
So really quick before we start, in case you're wondering, like dry ice, you don't have that in our kit. Okay, obviously we did not send you guys home with dry ice. And that is because you have to be 18 or older to purchase dry ice, and you have to make sure you're safe. So we're going to be doing some demonstrations because it's dealing with a lot of carbon dioxide. And so we're going to do some demos on dry ice, and then we're also going to do an experiment that you do have the supplies for that has to do with carbon dioxide. But if you were to handle dry ice, just a couple safety rules. Number one, have to be 18 or older to purchase it. Number two, you need to have on gloves. You don't want to handle this with your bare hands. It's 109 degrees Fahrenheit below zero. It will give you frostburn. It is extremely painful. It can really injure you. So we want to make sure we're handling it safely and have an adult. Also, we're not putting it in closed containers because it is a solid that turns into a gas, and that's too much pressure, and that's extremely dangerous. So we are going to be showing you some experiments here that we do with dry ice. But again, just want to make sure that you guys are being careful if you are using this at home. Alrighty. So we're going to go ahead and get started.
If I can open the bag of dry ice.
Let me help you.
Nope. So this is dry ice. The reason they call it dry ice is that it does not give off, it does not go from a solid to a liquid. It goes right from a solid to a gas. This is similar to what is frozen on Mars. This is frozen CO2. So it goes right from solid to a gas.
So instead of melting, like we would with ice cube that goes from a solid to a liquid, this is going to do what we call sublimation. That's going to be going from a solid to a gas, and that's why it looks so smoky. And again, don't call it dry ice, or you call it dry ice because you'll never have a puddle. Once it's gone, it's gone. There's nothing left.
So what we're going to do here is I'm going to show you basically the physical and chemical changes that take place when you mix dry ice with water and other substances. So go ahead, you take your dry ice and you're going to drop it into just some room temperature distilled water. Then, regular water is going to be of a neutral pH, and then with the dry ice, it's going to be, well, you'll see. I'm going to add some indicator, universal indicator, which is going to tell me the pH of the water now that the dry ice has been added to that, introduced. It's going to be red, and that tells me that this water is acidic with the pH. If you look here, the pH is going to be out of 4. That's all the way at the very end, whereas your regular water is like a 7. And so we're going to see what happens when we add a few other chemicals to our colorful acidic water. You would not want to drink this, obviously. Next thing I want to add is going to be ammonia, which is what's going to change the color again to a bluish, purpley color. A little bit more, makes it even darker. So if you look on our little handy dandy guide here of indicator, this is like between an 8 and a 9, so that's super basic. So ammonia is not acidic, it is a base. That's why it's making all these little fun soap bubbles. You can actually pop them. Once the chemical process has begun, it's not going to burn you, but it makes fun little
all that's trapped in it. Yeah, all that's trapped in it is
CO2,
carbon dioxide.
And now this is called carbonic acid, is what we've made. Well, it's carbonic acid when it's in acid form, not in base. So if I add regular vinegar, vinegar is acidic, like your vinegar chips, malt vinegar. It's going to take it back to that blood orange red color. And so now it is acidic again. And this is called carbonic acid. So we're going to let it do its thing.
Another cool thing you can do with dry ice, if you want to add a chunk of dry ice to that cylinder, what we're going to do in your cooler, and grab your dry ice out of there, is if you take your dry ice and put it in water, and obviously you get that really cool smoky effect, get that fog that's coming out. That's just all that water vapor that's escaping. That's why it's actually kind of going down the ground. It's heavier. But if you take and then this one called Science Hammer. And then if you just put some dish soap in there, you're gonna see some really awesome bubbles come out. This is something really fun. Again, you can do this for an adult at home, but the bubbles are super fun to play with. Just make sure your hands never go inside the cup. But any of the bubbles that come out, you can pick them up and you can kind of smash them with your hands gently, you don't want them in your eyes. But if you crush the bubbles, you're gonna see that awesome smoke come out, and that's gonna be your dry ice that's also gonna be escaping. So what we're going to do now is we're going to move on, and we are actually going to be doing a couple little rockets. And so I'm going to go ahead and move these cups out of the way, just give me some more room.
Well, that's good.
And then if you give me the cooler, I can make some smaller pieces.
Cool, that would be fantastic.
Yeah, there you go.
Super groovy. We're going to do a couple things here. You guys have the Alka-Seltzer tablets at home. You do not have obviously the dry ice. We're going to show you the difference between what dry ice does with these little Alka-Seltzer rockets and what actual Alka-Seltzer tablets do as well. But same process. It is just releasing carbon dioxide gas. Gets trapped inside the little film canisters. You guys are probably too young to remember film developer. Unfortunately, we do. So that's what these are. Just regular old film canisters. You develop your photos in here. But the CO2 gas is going to get trapped in there and cause a reaction. So, dry ice first, or do you want to do?
Let's do the Alka-Seltzer first.
Okay.
To kind of build up the dry ice. So yeah. So again, we're going to put this in. This is also Newton's law, so we're also doing a little bit of physics. Obviously, these aren't going to move by themselves. So the first law, an object at rest will stay at rest unless you apply force. Second law, force equals mass times acceleration. These don't have a lot of mass, they're heavy, doesn't take a lot to move them. Third law, for every action, there's an equal opposite reaction. That's why they're upside down. You want them to pop up. And so right now, all that gas is building up, and eventually there will not be enough room inside that canister. If you look, we've got one that's got a little puddle happening. You can go ahead and just, it'll go. And so the other one over there is actually definitely going to be launching. So this is just a waiting game at this point, because it's just going to be whenever there's too much pressure and it finally pops and it finally launches. And
Awesome.
so that is an Alka-Seltzer. You have 5 film canisters in your kit. You have Alka-Seltzer. This is an outdoor activity. We're doing this inside. We have a theater with a really high ceiling. However, you at home, don't do this at home. You don't want to break any lights or anything like that. Do it outside. So now we're going to do the same thing. We're going to do it with dry ice. So get a little piece of dry ice. And there's a little bit of water in there just to make it sublimate faster. Tap it. And then move out of the way for sure, because these go off a lot faster and you'll see a much stronger pop. So again, we're in a theater with a really high ceiling, and that's our ceiling in here. So we're gonna do one more, good snap, and then stand back.
Leaky bottom.
No, it might still go. Also, worst job in the world ever is if it doesn't launch and you have to figure out why, and you have to go in to pick it up.
Skinner.
And it's so bad because it's not happening.
No?
Somebody want to take the lid off that one?
Okay.
Carefully. Carefully. All right.
We're just going to put it aside.
It might still go off.
Might go off.
All right, so what he's going to do in the meantime, if you want to hand me that, I'll take care of that, and you can go ahead and do your bubble domes. So I'm going to give you all right, you can explain. If you want to hand me that little rocket, I'll take care of that. Thank you.
So right now I'm going to show you a little, just a fun cauldron type, spooky, creepy thing you can even do on Halloween. It's just dry ice with water and a bowl, a metal bowl like so. And it's going to be releasing that CO2 gas. But what we're going to do is create bubbles. Everybody likes bubbles, right? So you can see here, I'm taking my just regular dish soap and just going to go around the edge of the metal bowl with soap. Then you take a little rag, you cut up whatever cloth, tubing with soap. And then you're just going to want to create a seal with the bubbles. Same principle as with the Alka-Seltzer rockets. No, I didn't get it.
So this one is a little tricky. It takes a little bit of practice. What you're doing is you're trying to create a film of soap over the top of the bowl. And so you got to get a little bit of practice trying to get this. Sometimes it takes a few tries. That's normal. And so once you get a nice film across the top, what happens is all that carbon dioxide builds up underneath, and then you've got that surface tension happening on the top of your bubble, but eventually it's going to be too much carbon dioxide gas and it'll actually pop your bubble. And so right now, we're going, we might have this one. This is a very tricky process, takes a lot of practice. And I think we got it. And so now we're going to watch, right at the end, try one more. I said, this is like, Takes practice.
I did it yesterday.
I
but
know.
Maybe it's
No.
on camera.
That too. But no, it also just depends on if you've got a good like smoke happening in the middle that's popping it. Yes. All right. So what we're gonna do is we're just gonna watch.
Wow.
One more time.
We'll get it.
We'll get it.
We have time.
Yeah, we're good. And I said that's a thing with experiments. Sometimes you're not gonna get it on the first try. Sometimes you have to do it multiple times. Sometimes you get the right result. Sometimes you don't, and you just have to keep trying it. These are really cool when you do get them.
Awesome.
There you go. See? Patience. And so right now,
Yep.
that CO2 is building up underneath, and you're going to start to see that bubble rise. And so that's just carbon dioxide gas underneath. And the really fun part is you can just let it keep rising until it pops on its own, or you can actually pop it with your own finger, and we'll do that in a second when it gets a little bit higher so you can see it better. And then you get that really cool effect. If you like to do things like TikTok and make YouTube videos and stuff, this is a really fun video to do. Also to do it in slow motion, because the pop when you do it is really cool when you film it in slow motion.
It's going to pop here in a second.
Is that or you see
It's bubbling up.
That's a really good one.
And, we'll see.
So while we're waiting for that, I'm going to show you the next thing I'm going to show you with some dry ice. So the indicator we use in that experiment is called universal indicator. It's used for a lot of acid-base reactions, but there's other indicators. And so I have a couple different indicators over here. And so I brought out, these have some crazy names. So this one is thymolphenylene. And so this one right here is phenol red. And then I also have my bromothyle blue. And then I also have phenolphthalein. And so all of these indicators change colors based on acids and bases, but they change different colors. And so I've already put some in my cups of water here. And what I'm going to do is I'm going to add some dry ice to each cup. And what you should see is we should start to see it start to change color, because the pH is actually going to change color in the cups. And so we're going to add a little bit of dry ice. And so that one, you're going to see the color change happen like immediately. And dry ice here. And so this is our bromothyle blue, should show the blue. Actually, I think there's yellow first. And then we've got some phenolphthalein here. That one, I'm actually going to add a little bit of ammonia. And so I'm going back through and I'm adding ammonia. So now we've got our red, our blue, back to red. That one's staying clear right now. Then we're going to go back over with some vinegar and strengthen. So this one's going to take it back to yellow. This one, we should go back to that yellow and green. And that one eventually will go back to clear. So our indicators, again, they're just going to start changing colors based on that pH level. Now, the experiment you get to do at home, a little bit different. Obviously, we didn't send you home with dry ice. And so, but again, if your parents are willing to get some for you and you guys can do some experiments together, go for it. So what you got is you got a little portion cup. So you got a little portion cup of something called phenolphthalein. It is what we call the pink indicator. And so that was the one that was in this cup over here. That one stays clear when there's an acid, and it's pink when there's a base. So what you want to do, you're also given 2 cups. You want to put water in your cups. And so I filled my cup a little bit like halfway with water in both cups. And then I added my phenolphthalein, which is your little portion cup. This is phenolphthalein. I do want to stress we don't eat or drink anything in chemistry lab, and especially this. This is not something to drink, but you're going to put it in your cup. You also have a straw, and I'm going to explain why. You're going to be using your breath to make things change color. And you're going to do that twice today. So with this experiment, phenolphthalein, again, changes to pink in the presence of a base. It changes back to clear in the presence of an acid. Because your breath has carbon dioxide in it, it's acidic. So what we're going to do is right now the phenolphthalein's in there. I'm going to add a tiny bit of, we're going to go baking soda in here. And so I'm actually going to come over and add, I think, a little bit of ammonia in mine. All right. Because what you want is that pretty pink color that's going on here. And what you're going to do at home, and again, it's okay if yours just stays cloudy or if it goes pink, you're going to take your straw and you want to start just blowing bubbles into your cup. And that's why it's important that you don't fill your cup to the top, because when you blow bubbles, it's going to splash. And you don't want to have that splash on you. You want to keep that inside the cup. So you're going to take phenolphthalein, put it in the water. It's going to look cloudy. You can just leave it that way and try to experiment that way. Or you can take your baking soda and keep adding some baking soda until you get a pink color. And then you're going to start blowing into the cup. Now, it's going to probably take a few minutes. So I'm just going to start doing it. Not very exciting to stand here and watch me just keep blowing bubbles into a cup for like 2 minutes. So we're going to blow into the cup. You just want to be careful that you don't inhale because you don't want to drink any of this. So you're just going to keep blowing bubbles in the cup. And the more you blow bubbles in the cup, you're adding carbon dioxide to that liquid, and it's going to start to turn more clear. You can also let the cup sit out and leave it alone. And again, there's carbon dioxide in the air, and that's also going to affect it, and your cup is going to start to go back to clear. So this is just an experiment to show that there is carbon dioxide in the air, in your breath. It is acidic, and it will change the pH of the liquids that you are using. So those are our experiments for today. Anything else you want to add?
I just want to thank you for being here, and I'm glad that your students are enjoying this. I know middle schoolers, sometimes STEM is not super exciting, neither is history, so it's great that you guys are getting this content to them, and I just want to say we'll see you tomorrow. Have a great day, and obviously have a great school year.
And hold on, at 11 a.m. you do have your optional program
Yes.
you can tune into.
You need to keep her.
Optional today is live science show. So at 11 a.m. We will be doing live science show. We are going to be doing this with our Don't Try This at Home students that are here on site. We are going to go outside, and we are actually going to be launching a big garbage can using liquid nitrogen. So tune in at 11 o'clock. We'll be filming outside. You're welcome to join in, ask questions, watch the video. Hope to see you then.
Should be the same Zoom link too. Yeah.
It's a different one for them. They know.
Okay,
They
cool.
have their links.
Awesome.
They
Great.
got them.
Have a good day.